So let us continue from the last class. So in the last class I have given few equations, that is, if I have a function y equals to a into f of x, where a is constant, then you can take d by dx of y is a into d by dx of f of x. That's the first result. And the second one is, if y equals to f of x, z of x, then when you take differentiation, while differentiating you fix first function constant, then differentiate second function. Next you fix second function is a constant, then you differentiate next function. And one more result is f of x, if y equals to f of x plus g of x, then you differentiate f of x plus then differentiate g of x also. And similarly, if I have function y in x and x is a function in t, then if I write dy by dt, that will be equals to dy by dx into dx by dt. All these are the results we have discussed. Now let us continue the problem. The problem is here. For example, if I have y equals to, in the last class we have even done tan x. Now here I am taking secant x. Then what is the differentiation of this function? So what is dy by dx? So that is dy by dx of secant x. But I don't know what is directly what is differentiation of secant x. Now we need to derive from the basic thing. That is, let us write down this as dy by dx of, you can write down sec x as 1 by cosine x. So the 1 by cosine x you can write down as dy by dx of cosine x whole power minus 1. So this is what your function is. Now I have given one more the basic equation, that is, if I have a function that is y of n, then if you differentiate that function with respect to x, you will get n times y power n minus 1, then you get dy by dx. So this is the fundamental or basic result. So now we will use this result to answer this. So now I will use this result to answer this. So now let us see how I will use. And instead of y, what is that? Instead of y, look at, instead of y, you have cosine x. Instead of n, you have minus 1. Let us compare and write down the solution. That is, so now you can write dy dx equals to n is minus 1, and function y is cosine x whole power n minus 1. So n itself is minus 1, minus 1, minus 1. Then you have dy by dx of y is cosine x. So now that equals to minus cosine x, and minus 1, that is minus 2. Then you have here dy by dx of cosine x. What is dy by dx of cosine x? It is minus sin x. Let us write minus sin x. So now dy by dx equals to, so this minus, there is minus and there is one more minus. If you multiply, you get plus. Then cosine x whole power minus 2 can be written as 1 by cosine x whole square, and you have sin x. So now I am rewriting this one. So let us rewrite this one as sin x by cos x into 1 by cos x. There is one cos x here and there is one cos x, you get cos square x, and sin x is common. Now, so in this I can write down sin by cosine is tan, and 1 by cosine is secant x. So this is the result now. So now if y equals to secant x, then dy by dx will be, or you can write down like dy by dx of sec x equals to secant x into tan x. So this is the result. Similarly, you can do for cot theta, cot x, and cosecant. Let us do even that. So I am doing now the function y equals to cot x. So that you can write down as cos x by sin x. Then dy dx of this one will be dy dx of cos x sin x whole power minus 1. That is, so I told that there are two functions here, one is a cosine, one is sine. So you have to differentiate this one by keeping first function constant. You can fix first one is constant, then dy dx of sin x whole power minus 1 plus next time you take a sin x power minus 1 common, you differentiate cosine x. So if you do this, you get cos x for this, and for this one it is again once again like a d by dx of y power n. So in this you get minus 1 sin power minus 2 x into d by dx of sin x plus sin power minus 1 and d by dx of cosine x is minus sin x. So you get minus sin x. So that is, you can say here it's minus 1 into cosine x, that is minus cosine x. So sin power minus 2x, that you can write down as sin square x. Then d by dx of sin x is cosine x plus, and in this you look at this one, there is sin x and there is sin power minus 1x. So when you do that you get 1 and the minus sign is there, so you get minus here, minus 1 you get. Now this is cosine x, you get cosine square, that is minus cosine square x by sin square x minus 1. So that is, so this one is cot square x minus 1. So you can write down this as minus of 1 plus cot square x. So this is the result. If you take a function is cot x, your dy by dx will be minus 1 plus, or you can write down it as minus cosecant, or you can write down it as minus cosecant square x. So this is the result. Similarly you can do it for cosecant x. So let us do that even. So now my function is cosecant x, then what is dy by dx? So that is dy by dx of cosecant x is 1 by, you can write down sin x. So 1 by sin x can be written as sin x whole power minus 1. So that is, and again this one looks like d by dx of y power n. So for that you will take minus 1 sin x whole power minus 2, then differentiate that function, that is sin x. Now minus 1 and sin x whole power minus 2 is by sin x whole square, then d by dx of sin x is cosine x. Now I am rewriting this part as minus cosine x by sin x into 1 by sin x. Now dy by dx is, and look at this part, cosine by sin, that is cot x. Now let us look at 1 by sin, that is cosecant x. So this is the result. So if y is cosecant x, your dy by dx will be minus cot x into cosecant x. So this is how you can do. I have done all these, I have got all these results by taking differentiation of sine, cosine. Now let us take one problem here. Let us take a problem here, that is the function y equals to see, e power x sin x. Then what is dy by dx? Now dy by dx will be d by dx of e power x sin x. So this is like d by dx of f of x g of x. So when you have such situation, you first differentiate, you first fix one function constant, then differentiate second, plus fix second function constant, do differentiation for second one. So in this, I am fixing first e power x common. Then let us differentiate sin x. Next time I will fix sin x common, then I differentiate e power x. So now I will get result, that is e power x, then d by dx of sin x is cos x, plus then here I get sin x, then d by dx of e power x is e power x. So now if I rewrite this one, I will get e power x into cos x plus sin x. So this is what your dy by dx. If y is e power x sin x, so your dy by dx will be e power x cos x plus sin x. So this is how you. Let us take one more function. Now I am taking the function that is y equals to, let's say, x plus 1 by x. Then what will be the differentiation? And this looks like y equals to f of x plus g of x. Then to differentiate this one, dy dx equals to, you take dx dx, first differentiate first function, plus d by dx of 1 by x. So this is what you have to do. Now dx by dx is, that is 1, plus d by dx of 1 by x. So 1 by x can be written as x power minus 1. And this looks like d by dx of x power n. Now d by dx of x power n equals to n times x power n minus 1. So now here it is 1 plus minus 1, because that is n, x power minus 1 minus 1. So that equals to 1 minus x power minus 2. So this is dy by dx. So dy by dx is 1 minus x power minus 2. So you may take any function now to find the differentiation. For example, if I take one more function, that is, so y equals to e power ax plus sin bx. So this can be a function. Now this looks again like f of x plus g of x. So if you have f of x plus g of x, you can do differentiation, that is dy dx is d by dx of e power ax plus d by dx of sin bx. Now d by dx of e power ax, so d by dx of e power x is e power x. Then you have to differentiate once again that x with respect to x. So you get, so d by dx of e power ax is e power ax. Then you have to differentiate once again that whatever is there here, this part. So let us differentiate ax plus, and similarly the d by dx of sin x is cos x. So let us write down cos, instead of x you have bx. Then we have to once again differentiate this part. Once again we have to differentiate this part. So now that is d by dx of bx. Now this is e power ax. So I already told that when you have a function that is a into f of x, then while differentiating we can take that a common. So here it looks like the same. A is constant and x is some function. Then when you differentiate it, you will get a times dx dx plus cos bx, and here also it looks like same once again. You can take b common, dx dx. So then your final result, because this is 1, this is 1, then your final result looks like this. So a e power ax plus b cos bx. So this is what your dy by dx. So tomorrow we will start one more topic, integration.